Hi, welcome to Module 3 of Unit 1, where we're going to look at a really important part of a statistical study, which is doing correct sampling for our study. When we look at the actual process of a statistical study, it usually starts out with a singular question. We want to know something about a given population. So when we're asking the question, we first want to establish who is it that we're interested in finding out this information. That person or group of things that we're wanting to know information about is our target population. The thing that we want to know about that population is the thing that's going to vary from individual to individual within my population. That's the variable. The variable is the thing that we're looking at. The population is the general group that we're concerned about. Once we've defined that and decided upon a strategy, we're going to collect the data. And collecting data is probably the more important part of the statistical study because it's easy to go back and redefine or refine who our target population is, what our variable is. But once we've gone out and collected data, we're stuck with that. That's the only thing that we have to base our results on. So it's really important that we collect it in a way that makes sure it's free of bias and that it's representative of that population we're targeting. Once we've collected the data, then we do stuff with the data, and those are usually calculating statistics from those data, whether it's finding an average, whether it's finding a percentage, a standard deviation, all those different ways that we've looked at finding numbers from numbers, those are our statistics. Once we've calculated the statistic, we take that and we change it or use it as a way to estimate how we feel the population is close to that or not close to that. That's when we're estimating a parameter, which is a number based upon the population. We're going to look at that more here in a little bit. And then we take it back to the question. Did this answer our question? Did it not answer our question? And if not, then we start the process all over again. So that's sort of the circle of life of a statistical study. Some key vocabulary. Number one, we've mentioned this already, and population. The population, of course, is a particular group of interest upon which our study is focused. A population can be a very large group, and it can also be a very small group. A population can be women in the U.S., or it could be women at Tacoma Community College. It could also be just people in Math 46 online. It all depends on what information you're after. So populations can be very big or can be very small. A lot of times those populations are large. And so instead of polling everybody in the population, we choose to sample our population. So for example, if we were an educational group wishing to know the percentage of minorities within an urban school district, think about the wording of that question there or that scenario and decide what would be the population, what would be the target population of the study. The answer is students in the school district. A lot of people make the mistake and think that minorities are the key focus of this study. But the minority status of the students is really the variable in the study. The population is much more general. It's simply students. And students will either be in the minorities or not in the minorities, if that's the focus of my study. Second example, software maker wishes to know the operating system used by the majority of computer users. What would be the target population in this case? The answer is computer users. Computer users is my target population. The variable in this case is what type of operating system they're using on their computers. Just like in the previous question, the variable was their minority status. Good. So The numbers that we collect, the information that we collect is our data. It's the information that we gather from the population. If we're talking about a single data value, another word for that you'll see pop up every so often is datum, or usually I just say piece of information or piece of data. Census is if we gather information from every member of a population. This is typically not attempted with extremely large populations, such as women in the population or men in the United States. But again, populations can be really big or they can be really small, like a single classroom. So there are times where a census is doable. And if that's the case, we would just go ahead and proceed with the census as long as our population is small enough and that we can ensure every member of that population is reachable. When we calculate numbers from a population, because we conducted a census, those population numbers are called parameters. Parameters are numerical descriptions of a population. Again, this all depends on how big our population is. If it's small enough, then the parameter is something that we can actually find. But very often parameters are very difficult to obtain, if not impossible. Mostly because there's too many within the population and it's almost impossible to try to reach all of them. And so instead, we usually aim to just estimate what a population parameter is. We estimate these with samples. When we calculate a number from a sample, that number is called a statistic. A sample, of course, is just a subset of that population that we feel is reflective of the overall population. We choose this because simply it's easier to gather information about a sample. And a lot of times, because we can be sure about the size of our sample and we can be relatively sure that it's reflective of the overall population, given we followed some proper procedures, we can actually use this as an estimate of the population parameter. A lot of times, ironically, a sample that is gathered correctly can be a better estimate of the population number when the population is really large and we try to do a census. Usually that census is unsuccessful. It doesn't reach every member of that population. And so therefore our results are somewhat not accurate. So we actually sometimes get better results by using samples and then using some of the theorems and such that allow us to estimate population parameters from those samples. All right, so numbers that come from a sample are called statistics. Numbers that come from a population are called parameters. You can remember that really easily because parameter matches up with P, population, and sample S matches up with S in statistic. So population parameters, sample statistics. And we even, as you've noticed probably at this point as you're reading through the material, that we even use different symbols to describe each. In general, we use American letter symbols for sample numbers like S and X bar. And then we use Greek symbols, usually lowercase, to represent population parameter numbers, such as mu and sigma. Mu for mean of a population and sigma for standard deviation of a population. All right, so how do we get a good representative sample? This stage is even more of a science than some of the other things that we do. Like I said, it's very important that we get a good representative sample when we do a poll. Now, in every one of these different strategies that we're going to look at involves randomness. Random sample, by definition, is a sample in which every member of a population has an equal chance of being selected. So, if we want to do a random sample, and we don't want to get too complicated with our strategy, we can do what's called a simple random sample. And in fact, you can even just write in simple in front of the random there. Simple random sample. To do a simple random sample, it's something that you've probably done before. If you were looking for someone to win a prize, right, in a raffle ticket, what we do is we take all the stubs from people's raffle tickets and we throw the names into a bucket or a hat, and then we draw out a raffle ticket. And everyone accepts that as being a fair way of choosing a winner. Why? Because every ticket in that bucket or in that hat has an equal chance of being selected. So when you think of a simple random sample, we put everybody's name into the quote unquote hat, so to say, and we pick someone at random. If we're trying to be a little more complex about it, we might assign everybody a number and then have a computer or some sort of method of picking a random number to match up with the numbers we've created. So a simple random sample makes it very simple, very easy. We assign people a number and we pick random numbers. If we want to get a little more complicated, we can, and there's reasons why we do. Maybe I want to make sure that the sample that I pick has an equal representation of men and women. And so what we do is we take a stratified strategy in finding my sample. And I divide up my population into males and females. So in a stratified sample, we divide our population into strata, or smaller groups, and then from those smaller groups, we select random samples. So maybe, for example, we divide our population into male and female, and then we pick 100 males and we pick 100 females. This is just exercising a little more control over our sample so that we get, in this case, an equal representation of males and females. If we're doing a poll at a school, we may want to make sure that every class has an equal representation. And so we may divide it up by class, freshman, sophomore, junior, and senior. And then we might poll 50 people from each of the classes. Now, your groups that you pull from these strata do not have to be equally sized because maybe there are more freshmen coming in than there are seniors. So maybe we want to base our percentages, our samples that we pull from these, based on, so we have a sample that represents the percentage of students at the school that are in the various classes. So, and there's lots of ways that we can divide up a population. We can get really technical with that. But that's the basic idea. We assign members of a population into groups, and then from those groups, we take a random sample. Now, on the flip side, there's another way of approaching it that's somewhat similar, and these two get confused a lot with each other, but they are very different, and this is called a cluster sampling method. When we do a cluster, instead of dividing people by some sort of defining characteristic, we simply create small groups that we would consider each mini populations. So each little group that we've created, each little cluster, is itself somewhat representative of the overall population. So in a cluster sampling, we divide population into small clusters that are each similar to the population by themselves. And then we select random clusters from that area. Let's say that I wanted to know something about the Tacoma School District, and I don't have the numbers in front of me. I don't know how many schools there are in the Tacoma School District, but it's a pretty big school district. And so what we might do is choose 5 schools of the 20 or so that are in the district and focus our polls on those particularly randomly chosen schools. So in a sense, we're still sticking with the randomness in that each school had a random chance of being selected for my survey, and I have more than one of them, so I'm not getting just one district or one little area of town. Hopefully, with my random sample of the school districts, I've picked school districts that are scattered throughout the Tacoma School District. And then from those school districts, we would just conduct a poll of everyone within those school districts. So one of the things that distinguishes stratified from cluster is that once we've selected a cluster, everyone within that cluster is a part of the survey, okay, or is a part of the poll. In stratified, uh, sorry, in a stratified situation, we've divided it up according to some sort of characteristic, and then we take small groups from each of those characteristic stratas, right? So in a cluster, once we've selected a cluster at random, every person within that cluster is chosen. In a stratified, we divide it up according to characteristics and then take from each of those. Notice that in the cluster sampling, we didn't take 50 people from each school. That would make that a stratified sample. All right, the next one is a systematic sampling. And you kind of see this when maybe children in a classroom are selected for a team. They might just say, okay, every other person is on this team, and then the remaining people are on the other team, right? We consider that somewhat systematic. We're selecting every nth member of a population to be a part of my study. These are sometimes used a lot in assembly lines for quality testing. If they want to test their product to see that, to make sure that everything's being produced correctly, they may just select every 10th thing off the assembly line or something to that effect. That's systematic sampling, and we shouldn't use that if the list is organized in any way that might bias our sample. And then the last part is the sampling method that we want to avoid. And this is called convenience sampling. But unfortunately, it happens a lot. And so we want to be aware of it. If we're making it a little too easy for us to collect our sample, a lot of times that's just inviting some bias into our results. So that's one thing you can look for. If something's a little too convenient, we want to put our little flags up and say, hey, we might be running into a convenient sample problem because we're not getting something that's random enough for our study to be reliable. Usually it skews the data in some way. For example, if I just put an ad out in the newspaper to try to get people to participate in a survey, I would run into a convenient sample. Now, it's very easy for me to put that ad up there and then just sit and wait for somebody to call me, right? But the problem with that is that people will self-select themselves, and this is a really big problem in collecting an unbiased result. People who self-select themselves for a survey will tend to have really strong opinions about that topic, whatever it is that you're doing a sample of. And people who have really strong opinions, will usually fall on one extreme side or the other extreme side. The people that are in the middle who care but don't really care all that much, at least not enough to motivate them to select themselves to participate. And so there's a whole middle ground of people that you end up missing. And so self-selection is one thing you really want to avoid in a sample. Telephone surveys, again, where we put out a telephone number and wait for people to call, those are bad. Also, just calling people at random these days is also becoming slightly harder with all of the people switching to cell phones, etc. If you call on landlines, you're going to get a certain demographic of the population, usually a little bit older, that haven't switched over to new technology. And so again, you're biasing a sample toward a certain demographic. Not to say that telephone surveys can't be used. They just have to. You just have to take all of those considerations when you're doing it. So let's look at a few just example sampling techniques and tell me which of those that we just looked at. Again, there is, let me go back to the previous slide. One that I don't have listed here because we had it on the previous slide is census. Sometimes if we're targeting everyone within the population and it's reachable, we could conduct a census. A simple random sample is like names out of a hat. Stratified samples is when we divide people into stratas and then sample from each of those stratas. A cluster sample is when we divide our population into mini populations, and then which are clusters, and then we choose random clusters to participate in our study. Systematic is every nth member of a population, and then we have convenience, the one we want to avoid. All right, so our first thing is a pollster surveys 50 people in each of the senator's 12 voting precincts. Of the ones we just listed, which do you think that would be? The answer for that is stratified. This is a perfect example of stratified sampling. We've divided people according to their geographical location. That's our strata. And then the other important thing is we pulled 50 people from each of those voting precincts. So each of the stratas was pulled from, in a sense, and so that makes this a stratified sampling. The quality control department at the cereal manufacturer measures the weight of every 10th box off the assembly line. This would be systematic. We're systematically going through and grabbing every 10th box, so that's definitely a systematic sampling method. A female student walks down the hall at her sorority asking how much money each person spends on CDs in a month. This would unfortunately be a convenience sample. The student in question is most likely trying to target students at her college or wherever. And so if that's her target population indeed, to find out overall how much students are spending on CDs every month, then she needs to go outside of her sorority. For one, she's only getting a sample that has females. Males may have more of an inclination to go out and buy CDs. I don't know, but it's possible. And also, she's only talking to the girls that are in her particular sorority. And she's only talking to those who are there at the time. So there's a lot of problems with her strategy. It's very convenient for her. She can still walk around in her PJs and her slippers, but unfortunately she's not going to get a very good sample from that. All right, an educator chooses 5 of the school districts in the Chicago area and asks each household in those districts how many school-age children are in the home. In this case, this would be an example of clustering. We've picked 5 of the school districts in the Chicago area. There's probably 50, so 10% of them are participating in this survey. As long as they were chosen randomly, and then everyone within that district, relatively speaking, is participating in the survey, then that should give us a pretty good cluster sample of the Chicago school district. To determine who will win a $100,000 shopping spree at the mall, the manager draws a name out of a box of entries. This would be an example of simple random sampling. Again, names in a hat. And then the department secretary lists each professor and their salary in order to determine the average salary of professors in the English department at her university. This is a great example of a census. The department secretary in this particular study, they're only really concerned, and so their target population, is English professors at that university. And they're wanting to know what the average salary is for the professors in that department at that particular university. And so that's a small enough population that all we have to do is call up HR or the records people and get that information. So this is a great example of census data. In collecting our sample, a big thing that we want to avoid is bias. If a study is biased, then that means it's systematically favoring certain outcomes. Convenient samples lead us to that by making it a little too convenient to reach people for us when we aren't necessarily going to get a good sample. For example, if you just walk around and maybe we're doing a study on people's political persuasions for the upcoming elections, we may choose, okay, let's go to the mall and do interviews. The problem is, again, is that not everybody has an inclination to go to the mall. And so you may get a certain demographic of people that enjoy going to malls, while the people who don't are going to be left out of the survey. So depending on what your target population is, and again, based if you're doing a political study, interviews at the mall will not be sufficient enough to give you a good enough sample. However, if your study is based on the shopping habits of people at the mall, then interviews at the mall would be completely reasonable, because your target population has changed from people's political opinions to people who are shopping and what their habits are. So there are times where interviews at the mall are appropriate. But what we generally want to always, always, always avoid is a voluntary response sample. The people who choose themselves, so there's a self-selection involved, are people who generally have strong opinions about the topic at hand. Not that we don't want to hear from those people as well, but we just don't want to leave out the people in the middle who, maybe they haven't thought about it, but they plan on voting if it's a political issue. But there is that general population that might not have a strong opinion, but might lean in a certain direction. And so we want to watch out, especially for volunteer response samples. Those are the biggest things that problems that work themselves into sampling studies. This is why, for example, when you hear sometimes if you're watching news shows or maybe entertainment shows, they may want to do an instant poll on their show. And to participate in the instant poll, you've got to call a number to register your opinion. Those are, by nature, voluntary response samples. And what you will find is in those particular results, sometimes they weigh in the one direction or another. And again, what you're seeing is people with strong opinions participating, where the people who don't have strong opinions just don't bother to participate. We also want to be very careful about the way things are worded. We want to make sure that we're not making an argument for not voting, but choosing one side or another. We want to be as simple and as straightforward in our question as possible, avoiding language that might be inflammatory or might guilt someone or move someone to answer in a certain way. And that's the end of the Module 3 PowerPoint presentation. Make sure that you read through also the part in the book for Module 3. You'll find some other information in that as well that'll help you in understanding how to get a good sample.